everyone, today is day 27 of Python Pro by CTC. Today we are delving into the concept of queues in Python. A queue is a fundamental data structure that adheres to the first and first out principle. Picture a queue at a ticket counter. The first person to join is the first person to get served, right? Queues in computer science operate in a similar way, making them indispensable in various programming scenarios. So what exactly is a queue? A queue is a collection of elements with two primary operations, that is enqueue and dequeue. Enqueue, which adds an element to the back of the queue, and dequeue, which removes the element from the front. The first element added is the first element to be removed, creating an orderly and sequential structure. As one can guess, queues have various practical applications, such as request handling in web servers. Queues are used to handle incoming requests in the order they are received. It is also used in task scheduling. Queues are used to manage and prioritize jobs. This is the skeleton of queue in Python. So the front is called head or front, and the back is called back or rear. So if we are removing an element from the front, it is called dequeue, and if we are adding the element at the back of the queue, it is called enqueue, as we have seen before. So this is how the job scheduling or any other queue applications work. For example, let's say there is job 1 here, job 2, job 3, job 4, job 5 and job 6. So if we are going to execute job 1, it is getting dequeued from the queue, so it will be removed from the queue, and if another job is assigned to the processor, it will be coming here, that is enqueued at the back of the queue. It came last, right? So it will be added at the last. Unlike stack, which got a last in first out FIFO principle, this got a first in first out FIFO principle. In stack, if we are adding an element, it will be coming out first, but if we are adding an element at the last here, it will be coming out at the last only. The first element to get added in the queue will be the first one to get served here. So this is basic enqueue and dequeue in queues. So this got as you can see, to access elements in the queue, the time complexity of O of n, that is linear time complexity. To search element by value, again O of n, and insert and delete, that is enqueue and dequeue have the time complexity of O of n, that is constant time complexity. This is the Python implementation of queue. We are going to use a list to implement queue in Python. So here we have initiated an empty list, then front equal to none because the queue is empty now. While true, we will be printing this. The user can select one of these operations. Then we will be executing these operations. So let's see the operations. So you will be checking if the queue is empty. If it is empty, we will return true. If not, we will return false. We will be using this empty function later in dequeue and other functions. So enqueue. As enqueue is adding an element at the last, we can just use append method to enqueue elements into the list. So to enqueue, we will be having two arguments, that is the queue itself and then the element to be added, that is I. If the length of queue after appending is 1, then front and rear equal to 0, that is that it will be at the 0th index. If not, the rear index points to len of q minus 1, that is the last of the queue. Then dequeue, it will check if the queue is empty or not. As we have learned in stack, underflow and overflow are two things. Underflow is where we are trying to remove an element where the list is already empty, and overflow is where we will be trying to add an element where the list is already full. So if we are trying to remove an element from the queue which is already empty, it will just return underflow. If not, we will just pop the 0th element, then we will return the element itself. Then peek means we are going to see the first element, that is the front element of the queue. If the queue is empty, again we will just return underflow. If not, we will return the front element. Then display. Again, display is where we are going to see the whole queue. If the queue is empty, it will return empty queue. If the queue has only one element, it will just print the element. If not, we are going to iterate through the whole queue. front equal to 0, rear equal to len of q minus 1, that is pointing to the last element in the queue. Then we will just print the first element, that is q of front. Then from range, then for a in range of 1 comma rear plus 1, we will be iterating through every element in the queue except for the first element. We will have everything here. So let's see how this runs. So 1 is NQ, 2 is DQ, 3 is peak, 4 is display, 5 is break, that is exiting. If not, if we are giving an invalid choice, it will just print invalid choice. So in NQ we are just adding the item. In DQ, if it returns underflow, if the function returns underflow to this if condition, it will print empty queue. If not, the popped element will be returned, so it will be printed here. Peak works in the same way, and queue and for display we have printed everything here itself. So let's see how this works. So first we will enqueue something, enqueue 2, again we are trying to enqueue. I have added 3 elements here, 2, 5 and 6. Let's try to display everything. 2, 5 and 6 have been printed. Then we'll try to peak. 2 should be printed. Yeah, 2 got printed here. Now we will try to DQ something. So in DQ 2 should be removed. Yeah, 2 got removed here. Again 5 should be removed. So if we are giving some invalid choice, it will return invalid choice. If you want to exit, we can just exit this.